Good morning, good afternoon, good evening, and welcome back to Ask an OpenShift Admin Office Hour. I am Chris Short, executive producer of OpenShift TV. I am joined by the one and only Andrew Sullivan. Andrew, long time no see. How you doing, buddy?
Long time indeed. It's been 3 weeks since our last stream together. I saw plenty of you. You didn't see any of me. I was watching your streams all during Summit, all during KubeCon. So
Well, thank you.
yeah, and I enjoyed that. It's nice to be a participant sometimes.
Yeah, I got some of
Enjoyed.
that during KubeCon. It was kind of nice. Yeah.
Yeah, enjoyed all the streams. Tons and tons and tons of content that came out of the last 2 weeks. If you're keeping up with all the feeds and all that other stuff around the stream. Uh, I have added yet another Slack team, Slack channel to keep an eye on, which is the CNCF Slack. So if you're on the Kubernetes Slack, there's OpenShift channels, there's OpenShift-users, OpenShift-dev. If you're on the CNCF Slack, there's OpenShift channels there, or Red Hat channels, I think there. In addition to all the other places. So we are constantly, always, never not available, I guess. If you need help, if you want to ask
Someone
questions.
is always around.
Yeah. There's always folks around. So hello, welcome to anybody who's new or hasn't been to one of the streams before. As Chris mentioned, I am Andrew Sullivan, one of the technical marketing managers with the Cloud Platforms business unit. So Chris and I both focus on OpenShift, and in particular, we bring an administrator background, right? We were both administrators, architects prior to being at Red Hat. And we bring that perspective. And really the goal of the office hour series of sessions, which the Ask an OpenShift Admin is one of those, is to give you, our audience, the opportunity to, well, ask us anything. Whatever it is that's on your mind, whatever it is that you have questions about, that's bothering you, that you're curious about, right? Ask us. And you can do that at any point in time across any of the platforms that you happen to be viewing us on. So if you are watching on the Red Hat YouTube channel and you post a question, we'll get that over on Twitch as well as in the OpenShift YouTube and kind of all together there in the circle, and we'll address those here. If we can't answer those questions, we're happy to follow up as well. Like I said, both Chris and I have an administrator background. You are more than welcome to ask about developer type topics, but there's a pretty good chance we'll have to follow up and answer those questions afterwards. So today, as the title probably gave it away, we're here to talk about CoreOS. So CoreOS is I'm going to say a flavor of Red Hat Enterprise Linux, but really the people who absolutely know whether or not I should be calling it a flavor or not are here with us today. And that is Mark Russell on the product management team, and Derek Ornelas, and Derek, please correct me if I butchered that, on the engineering team. So I'll start with Mark, if you don't mind introducing yourself.
Sure. Hi, everybody. Mark Russell on the product management team. Kind of have one foot in the business unit that deals cloud business unit that does OpenShift, but really I report up through the RHEL organization because, as Andrew said, it is RHEL CoreOS is a distribution of RHEL. Maybe we'll set that for another topic. We'll continue on in that in a moment, but. Otherwise, yeah, I'm also, an operating system administrator type background, and have worked for multiple distributions. And though this is my last one for sure, and as well as worked on the other side of the fence, consuming products and shaking my fists at software distributors. So I've been in a lot of different seats, including support as well. So, Derek.
Hey, so I'm Derek Ornelas. I actually wear two different hats. I do product experience for our container ecosystem inside of Red Hat. That basically is me bringing over a decade of support experience to the portfolio lifecycle management group. The other hat that I wear is RHEL product owner for RHEL CoreOS. So I'm kind of talk to the clients so the engineers don't have to kind of joke there. Yeah.
We had an intern on our team who we strongly encouraged to watch Office Space, and he watched about half of it and said, "I don't get this movie," and just stopped.
My kids, that one aged well with my kids, actually. That did.
Yeah.
Not as good as Ferris Bueller, but it did pretty well.
Yeah.
So, and Mark, so we already have a question for you, which is coming from JP Dade. Is that vinyl behind you?
It is.
Nice.
I like it for its inconvenience and collectability.
Wait, you can't play records in your car? I don't understand.
You can't hit shuffle on the turntable? No, you can't. And that is actually one of the virtues.
Nice.
And I don't know if you have the chat up, but I think that's Joe DeAndrea is saying hello, and also
Hi, Joe.
vinyl. So
good to hear from you.
Yeah, I've never. I'm right on that cusp of vinyl and all of that other stuff. I've never taken it up as a hobby because I've got enough things to occupy my time that my wife would object if I had any more. So, yeah. So thank you again. Whoever's watching, please feel free to ask questions in the chat. I see Samuel. How does Cloud Pak work with OpenShift?
I got a link.
Okay.
Unless you got some commentary.
So at the high level, Cloud Paks are a workload to OpenShift. So essentially, you're deploying an OpenShift cluster, right? OpenShift is OpenShift. And then the IBM Cloud Pak, whichever one you happen to be using, is deployed as a series of pods, right? Standard traditional Kubernetes workload on top of that. So that's really the way that we look at it, the way that we treat it. And then if you happen to be an IBM cluster, essentially they bundle, or customer, excuse me, they bundle everything together.
Yeah.
So that's where the magic happens. So for anybody who has joined us before, you know that I tend to open these sessions with just 5 or 6 minutes of things that are kind of top of mind over or since the last particular episode.
Ooh.
So it's been
time
3 weeks.
for
So
top of mind there.
So I had to pare this list down pretty substantially because, of course, with Summit and KubeCon, there was a lot that has happened. So I don't have any of the links right here. If you go to openshift.com/blog, and Chris might even have a shortcut for this, we've got a bunch of summary blog posts on openshift.com that cover all of the announcements, all of the things that happened. So I'll include those in the summary blog post. So Friday mornings, we have a blog post that goes out that includes all the links as well as references to the content that we have today, including links directly to the timestamps. So I'll put all of those into the blog post that goes out on Friday, but just know if you missed anything, if you weren't able to watch any of the sessions from the last 2 weeks from Summit and KubeCon, tons and tons and tons of great information. So I won't reiterate or rehash that because those specific presenters can do a much better job than I can. So I do want to talk about a couple of things, however. So I'm going to share my screen real quick here. And I think I want this window. I do. All right. So the first thing that I want to talk about, and this is it came from a conversation amongst the product management team. So one of our account teams asked the OpenShift product management team, and I happened to find this particular article that was shared as a result of that. So we get asked fairly commonly about stretching an OpenShift cluster across multiple sites. So one cluster that is on, maybe in data center A, with node 1 and node 2, control plane node 2 is in data center 1 and node 3 is in data center hashtag or something like that, right? #. So what are the requirements of that? Is that supported, right? How can I do that with Red Hat and with OpenShift? And the answer to that is oftentimes very nuanced, right? In that it's not unsupported, but there's a lot of things you need to be very careful about. And this KCS, if you read through it, goes through a lot of those things that you want to be aware of and what are the actual, guidelines and requirements where it becomes unsupported. So things like network latency, storage latency, right? Availability, right? What are some of the reasons why you want to do this or don't want to do this? And the impact that it has to availability as well, right? If you only have 2 sites, you're not really gaining any availability by spanning it across 2 sites. You're just increasing complexity, right? Those types of things. So great KCS, one I didn't know about until just recently. I wanted to share it with all of you as you're going through doing any architecture or making any decisions, because it does contain just a bunch of links to additional information that can be very useful for Let's see. Oops. Switch over, make sure that there's, thank you for posting the link, Chris.
No problem. Thank you for having show notes.
Yeah, I know. It helps. It helps keep me organized.
It does.
So if you weren't aware, upgrades from OpenShift 4.6 to 4.7 are now available. So finally, OpenShift 4.7.6 was or 4.7.7 was the first version where we fully opened that up. Remember, we've talked about this for, I don't know, like a month and a half now, since almost since it was 4.7 was GA'd.
A bug.
Yeah. So the issue was a bug with networking and VMware hardware version 14 and later, and the RHEL 8.3 kernel used by OpenShift 4.7. So the end result was, or the short version is, doing VXLAN offload caused some packet loss issue. So if you're using a UPI or IPI deployment, click that upgrade button, right? You'll be great. Everything will go fine. What you'll see is that the remediation was to add a machine config that disables the offload in the kernel.
Nice.
If you have an OpenShift cluster that is deployed non-integrated, right, or platform equals none, bare metal IPI or UPI, excuse me, whatever phrase you want to use to describe that, on vSphere, you still have the potential of experiencing this problem. So the way to fix that, or there are two ways to fix that, I should say. So the first, let me say, this has been updated. It is now in the release notes for OpenShift 4.7. And I'll post this into our chat here.
Thank you.
So if you look at the release notes for 4.7, we have this bullet here about running a cluster on VMware with platform equals none. You can see one of the recommendations we have here is to downgrade or to use virtual hardware version 13. Essentially, version 13, we're not seeing that same issue. So that's one of the options that is available. However, if you choose that option, remember, if you're using the vSphere CSI provider, that requires virtual hardware version 15. So you might have to do some balancing there. I say that also knowing that you, unless you have done something unnatural, like you deployed with platform equals none and then manually added the cloud provider for VMware, the CNS provider needs the cloud provider integration, or the cloud native storage CSI provider. So in theory, you shouldn't be doing that with platform equals none. So you should be safe there. The other option is to basically do the same thing that the vSphere problem detector is doing and the machine config is doing, which is to apply a machine config that sets the value for you. So I'll post this link inside of here. So there's nothing, again, if you have a bare metal or a non-integrated install on vSphere and you're using hardware version 14 or later with OpenShift 4.7, you'll want to effectively either use VM hardware version 13 or apply something like this as a machine config, which will go in and it will disable that offload. And that will avoid the packet loss issue that we've been seeing that led to the delay in upgrades. Hopefully that made sense.
Makes sense to me. If you have questions, feel free to ask.
Yep.
Yeah. Oh, I forgot to drop our special office hours thing.
Oh,
there we go.
Keeping in line with VMware. So I talked, it might've been the last show. I talked briefly about how, and for sure it was when Catherine was on a month or so ago, you can add nodes to an IPI cluster outside of the machine set paradigm, right? You can manually provision nodes, you can bring them into the cluster, and you can set them with like a static IP, for example, all that type of stuff. So Michael McNeil here published a blog post on OpenShift.com that walks through that process in excruciating detail. He did a phenomenal job here of documenting in screenshots every step of the process that you need to go through to deploy those nodes. So great resource. I find myself doing this process. Like I'll deploy an IPI cluster. I've been doing a lot of testing lately with using alternative or different load balancers with an on-prem IPI deployment. So what I found myself doing is I deploy an IPI cluster and then I'll manually provision statically IP'd nodes to act as my infrastructure nodes, and then configure the load balancer to use those statically IP'd nodes. Right. So anyways, one of the ways that you can make those OpenShift clusters more flexible to do the things that you need to do. And you can also manually create, you can create a machine, and I believe it will automatically provision that way as well, but don't quote me on that. I need to test that is what I'm saying. Oh, the last thing that I have is wherever I can find it. So speaking of using an external load balancer with the on-prem IPI, so with OpenShift 4.7, we GA'd and fully support this apps domain configuration. So even though this says on AWS, it's actually supported with all infrastructure types. The documentation is wrong. There is a BZ for that. But what this does, so you update the ingress here, you add an apps domain. And what that does is all routes that are created now use this domain instead of the default apps.clustername.domain name that's configured out of the box. So if this domain name, whatever that domain name happens to be, if that DNS address happens to reside on an external load balancer, now all of your traffic is flowing through that external load balancer. So it's one of the ways that you can use that. The other one being, or the other major one being, to deploy a second ingress controller. So for example, using the Nginx operator or the F5 operator to create a new ingress controller, and then configuring your routes, your applications to use that. Okay, that's all I got. I'm done.
Sweet.
Yeah.
On with the show.
So CoreOS. So Mark, I'll ask you, and Derek, please, I'll trust you guys to answer however you feel is appropriate. But can you tell us about Red Hat Enterprise Linux CoreOS? And I think importantly, kind of where did it come from? Like what is it? Why is it different from RHEL? And where does it fit into the Red Hat portfolio?
Sure. So let's, I guess I can start by going back even before, before it was a thing, after Red Hat acquired CoreOS, incorporated, the company, and they had a philosophy that they'd already started, a path they'd already gone down with container Linux. And container Linux had as one of its primary goals to secure the back end of the internet, the same way that Mozilla and Google had helped improve security on the front end by updating their browsers like very aggressively, right? So container Linux was going to do the same thing. It was going to by default update automatically, and it also is where Ignition came from. Which maybe we'll put off talking about Ignition, but that is also the origin of Ignition. It's the origin of the operator pattern as well, came through CoreOS. So we also had Project Atomic on the RHEL side that used used RPM OS tree as an alternate package manager. You could call it a hybrid image and package manager. So it deploys images, but it does understand RPMs. It does understand Yum repos. We don't make a lot of use of them, but it's there for troubleshooting and problem solving. And actually upstream, not in any product yet, but upstream RPM OS tree now understands RHEL modularity. So it's gaining a lot of abilities to understand other package systems, but at heart, it's an image-based system.
And upstream is Fedora CoreOS?
That's where you're going to see, I think, most of experimental features are going to land first in both Ignition and RPM OS tree. They are both also used in Fedora CoreOS, and that's where you're going to see the latest features land. So we took the CoreOS philosophy. As you know, and if anybody doesn't know, I don't want to scare anybody off. The updates are not automatic on an OpenShift cluster. You do have some interaction there. They're rolled out automatically once you decide them. I'm just saying it is in your hands. So we combined a lot of their philosophy and their approach with our expertise in SE Linux, the RHEL binary package foundation, and the battle testing that gets out there, and combine that with the provisioning stack, Ignition, and RPM OS tree. So you end up with a product whose philosophy is, it's a opinionated and distribution of RHEL that is built to serve the needs of OpenShift 4. That is, in the same way I think about when they talked about cryo being, only aimed at the needs of Kubernetes and no other use cases. That's the kind of the way I look at the relationship of CoreOS to OpenShift. It doesn't do much standalone. We don't sell it standalone. And so to get further into what is the philosophy, why RPMOS tree and why ignition? Actually, maybe I should stop if you have any questions.
So I like to talk about ignition because ignition is fascinating to me.
Yes.
It's a configuration tool that runs before PID 0 even starts on the system.
Which is
so you can do some really cool stuff inside of it. I also want to ask about and talk about so that's step one. Step two, or question two, is the management philosophies or the administrator experience and the difference from a RHEL administrator and OpenShift 3 to a CoreOS administrator and OpenShift 4.
So to the philosophical or management approach first, I think. You think about RPMOS tree, and I think maybe people are aware, but it's a read-only /user, so all the OS binaries are read-only, which has some nice security effects. But the real neat thing about it is you can actually, it's a clear separation between what we've distributed, the OS vendor has distributed to the customer, and anything that has been layered on top, or any changes that have been made. It makes that very clear. And that is an implementation of the philosophy, which is we want a clear, bright line between the platform that you receive, that you should treat in kind of an appliance-like fashion, and the user workloads and third-party agents as well. But there should be this distinction where a container host should be small. It should have a very small attack surface, should have as few packages as possible. And should be built, again, to run containers in an OpenShift cluster. Go ahead.
I hope that I am not getting ready to open a can of bees.
Oh, are they murder bees or?
No. Well, I hope not. So immutability and CoreOS. Can you talk about that?
Not murder bees. Got it.
Yeah, something short of murder bees, but it's a perfect question. It comes up a lot actually, and it throws people off a little bit. Immutability doesn't mean you can't not configurable, right? It doesn't mean exactly not changeable. Actually, you can kind of look at the way we distribute RHEL CoreOS in the same way you'd work with containers themselves, right? They are read-only, usually images that are configured by the environmental variables, right? You don't change them, you don't configure the individual containers. You have a set of configuration that is passed with this image. That's what we do, except we pass that configuration, or we have that configuration through the fact that etc is persistent. So user is read-only, /var and /etc are read-write. /var has a lot of state to it, and etc has your configuration as you would expect. But we do not support, outside of in production, managing those files manually. People do it. You can do it all, to your heart's content when you're trying to figure out what's going on in a problem. But in order to push out a change or a configuration change, you want to do that through the machine config operator and use a machine config.
And we should probably also mention things like the file integrity operator, right? So if you want to, basically know or verify if something has changed on the CoreOS system, the file integrity operator is the best way to do that.
The best way to know if any files change or have been added, because there is some confusion with the machine config operator that it is somehow watching out over all the files in etc, and that's not the case. If you want that level of, I need to know if anything has changed, and report that. So the file integrity operator comes in. It uses the advanced intrusion detection environment engine, whatever the E is, that I think people are familiar with. It's similar to Tripwire in that sense, right? So you just have a hash list of all the files and directories on the system.
Okay. So I don't want to forget about ignition. So can you talk about ignition and like, what is the purpose of ignition? And you know, we talk about it a lot in the installation process, right? OpenShift install, you know, you generate the ignition files. If you're doing anything other than IPI, you're hosting those somewhere, or providing them to the VMs. So, you know, what does that do, and how does that work? And importantly, can I modify those? Can I customize those?
And we will, well, I'll start with what's the difference. So a lot of people are, you know, from other distributions are familiar with Cloud Init, which is a post pivot, you know, post init ramfs utility that uses it seems to be like a combination of imperative and declarative configuration, and it's the most widely used, you know, cloud instance utility. Ignition, as mentioned, is a pre-pivot init ramfs utility that runs a single time, right? So this is it configures it can carve up disks, it can write files. Derek, feel free to jump in, but you know, a lot of stuff it does is carving up disks and file and various instances of configuration files.
Yeah, laying down files. Yeah, so stuff that you couldn't do post pivot with something like Cloud Init. You know, so we get to run you know, very, very early in the boot process before we've done anything with root from memory. We can you know, like lay down encryption, move the root file system to another disk or another partition, create secondary partitions, and you know, with the ability to define files like systemd units, we can lay down, you know, secondary mounts or systemd services that we want to run, you know, on the actual like provision system.
So you just opened up, you know, Pandora's box. I'm avoiding worm analogies now because Brett's given me a hard time about it. So a whole Pandora's box of questions for me. So things like, so ignition only runs once pre-pivot. Is that once per boot or once per system install? And I ask that because, like, if I look at a machine config and I look at a you know, in a machine config pool that has this rendered machine config, I can go in and I can do things like change the SSH keys, you know, the authorized keys, and that's defined using the ignition spec, right? So if
it's a subset of the ignition spec, and that, you know, understandably, I guess that can cause a little bit of confusion, but you know, using that subset allows people to, if they have an understanding of the ignition spec, to easily write those kind of configuration, define those kind of configuration changes. But the way the two function are vastly different under the hood. So, you know, you have ignition, and then you have later post install, day two, whatever we want to call it. We have the management of the system via the machine config operator, and it uses that same syntax, but the way that it goes about doing that is a bit different. It's also, since we are post install, post pivot, the machine config operator can't do things like disk manipulation, file system, etc.
Okay, so essentially, it's a single syntax, a single quote unquote language, the ignition spec, to define configuration, but ignition itself only runs once, and that's before system installation, effectively.
Mm-hmm.
And then machine config is effectively just leveraging the same syntax, but applying that configuration day two and later.
Yep. And so for a lot of things, like Derek was saying, if you wanted to redo the RAID capabilities and whatnot, things get really complicated. You want to, you know, you've moved the node from state A to state B, and now you want it to be in state C. It's simpler to just delete and redeploy in that state C. It's just a simpler problem to solve as well, and a cleaner way of looking at it than trying to move from state B to state C. And so that is kind of part of the philosophy. It doesn't mean that, you know, and the reason why we have a machine config operator is we're not taking that philosophy so hardcore that any configuration change requires a redeployment. We don't want to be that cruel. I did want to go back though and just say that and we can talk about how you use MCO, how you use machine configs to change configuration on the host, and there's some absolutely necessary use cases for that. Ideally, we prefer that vendors and users adopt a more cloud native approach. Like things should be containerized if possible. You don't need to write configuration files to Etsy. You can use a config map. There are ways of doing this to kind of get away from the details of the host, if that makes sense.
Makes total sense.
Yeah, it does. And so you mentioned, we don't want to be cruel and require a node reload for every operation. Are there certain things that we should, or we do want people to do a node reload? And I'll, before you answer, I'll say, Andrew tends to recommend that you configure the network interface that is on the machine network.cider using pre-boot. So kernel parameters are in the live ISO and copying that over. And if you want to change that network config, you reload the node. But are there other things? Is that even a good idea? And two, are there other things that you should be doing that with?
Derek will correct me if I'm wrong, but you are following our support policy and documentation on the networking. Changing the primary networking after deployment is not really supported right now. Secondary networking cards are a different story, and that's moving in the direction of using something like Kubernetes NM state to have a declarative, stateless sort of way of deploying network manager changes. But I don't know if I don't think is going to apply to the primary. But to answer your question, reslicing up the disk, changing the RAID array settings if you wanted to. And just a little plug, as of 4.7, we can even show a little bit of how this works later. We have support for software RAID 1 mirroring of the boot device. A lot of people don't like having to pay a lot of hardware, and they may have remote nodes that they can't send folks out to swap drives. This buys them a lot of time if they want, and without having to throw in a few $100, whatever the going rate for the RAID card that they would demand would be. So I just want to give props to the team for bringing that feature in 4.7.
Yeah, that's I didn't know about that. That's a big one, particularly
awesome.
For the remote worker nodes, right? Network Edge.
Yep.
Single node OpenShifts in the future. I see that being a big one.
Yeah.
So we do have a question here from Apostolos, and apologies as always because I'm terrible with names. Just ask my children. Can I change network configuration post-installation by modifying NM connection files in Etsy Network Manager System-Connections?
It is it is technically possible to do. So we're using Network Manager. Not only are we using Network Manager from RHEL on the system, but we're also using Network Manager to configure networking in the NetRAM FS phase. For example, if you guys have done a bare metal installation and you've used those boot parameters, IP equals, etc., Network Manager is writing out those NM key files. If you use -- copy network with CoreOS installer, those configuration files are being copied into the installed rootfs. It is technically possible to modify those to make those changes. It's not something that we necessarily recommend because you would have to do that manually. It's not necessarily possible to do that with the machine config operator and a machine config today based on the architecture we have with machine config pools. So we kind of expect, you would probably want to make an overarching change to all or a subset of your nodes. And as you can imagine, like say static IP network configuration settings or the alike they're node specific. and the architecture doesn't really cover that use case.
So I'll ask a question that I get asked quite frequently, which is like, and it's basically an extension of this, which is, day 2, I need to modify the configuration. So it's technically possible to SSH or maybe even debug into the node and put in those network manager config files to have it configure those interfaces. Is that, I know we discourage doing that, really favoring nm state, even though nm state is also tech preview, I think, in 4.7. Is that something that we support?
It is. I don't know, Mark, if you want to. It's not something that we. The process itself is not something that we support. Now, certainly, a lot of users have concerns about this. Just because you do it doesn't necessarily negate support for your cluster itself. I mean, it should work. We just, at the moment, there's no mechanism to do that in the way that we're imagining that you would manage your clusters or the nodes in your cluster today, in kind of a Kubernetes native fashion.
Yeah, I like that answer. I think it makes sense of, like, yes, it's technically possible, but there's a lot of ways that you can break something, and then it's going to be a bad day for you. And our support guys are, they're going to do their best. They always do their best to help, but sometimes it can be in an unpredictable configuration. So,
but that said, right, if something works in your lab, again, as Derek said, we could break it in the future, right? Like, so if something's unsupported, we don't consider that a persistent interface. But at the same time, you haven't scratched the sticker off, and opened the device to the point where now you've voided the warranty. If the support case, if you did that 2 years ago, nobody's going to say, aha, you changed your network.
Foiled again.
Exactly. We'll never get that cluster supported. So I don't mean to sound like full-on encouragement, go for it, but at some level it is your cluster. And if you can make certain things work, then that's more power to you. I'd be careful about the networking, and I would be careful. I would also just, get comfortable and get familiar with redeploying, though. I mean, it's not that bad. I'm on the workers. I know it's a little bit of a trick on the masters. It's a little bit harder. But it's not that bad on the workers, and sort of try it. Maybe you like it. You can even do things like we added a feature for a customer, for a couple of customers, that you can do the CoreOS install and preserve the existing partitions. So if you wanted to save the container cache, right, like so that a new node doesn't take so long to warm up and instantiate a new containers, because it has to pull them from the registry. You can just keep that. You could keep that through the install.
Oh, interesting. So if you're using a separate partition for, I think it's var-lib containers. Yeah. So you can persist that, and it'll just redeploy everything else.
Yep.
Very cool.
Nice.
Yeah, that was what you said there. Of, at the end of the day, it's your cluster, and you do have a surprising amount of leeway in the things that you can do. That was something that started to click with me when Catherine was on the stream, and she was pointing out things like, well, when you end up, when you deploy UPI or IPI, you end up with basically the same cluster, right? Just because it's IPI doesn't mean you can't manually add nodes. And for me, that was like a light of, oh, I don't only have to use machine sets to add nodes. I can still add those. Just like with UPI, you can create a machine set and deploy nodes that way. So
thank you for passing that on. Today I learned.
Yeah, it's one of those, like, we make assumptions, and I didn't even realize that I was making an assumption about it, and she very helpfully corrected me. So we have a question here from Mr. Chu.
Mr. Chuku.
Yeah.
I don't know.
What could be the best way to keep secrets on OpenShift, a way that is scalable, maintainable, and in line with best practices?
I love that word, best practices.
Yeah. So I don't have an authoritative answer for you here. I'm going to say, so secrets themselves, right, can be used, right? They get stored in etcd. If you're encrypting etcd, of course, they're going to be encrypted on disk, that type of stuff. There's third-party options, right? HashiCorp Vault. There's a number of them. I think was there something included with ACS or something like that, or am I thinking of something else, or ACM? I don't remember.
I don't know.
So we'll probably have to follow up with that. And I also know that there's some work going on upstream in Kubernetes with CSI, using CSI objects to hold secure secrets. I know there's some work going on there. So yeah, and hello, it's SK Routh. So thank you for tuning into the stream. We do appreciate everybody who does watch. So I'm going to ever so slightly course change here, because I want to make sure that we have time to talk about something that when I talk with partners comes up on a somewhat regular basis. I also see it come up with particularly public sector customers. And that is, how do I add agents and drivers that are not containerized? Like, my security team requires every host to have an AV agent installed on it, right? CoreOS or not, I don't care, right? It has to have AV on it. How do we address that?
I think that's a tricky one. I think there's categories of agents, and when I end up talking to customers, and you get to the point where like you triage them, the best way to do is just start listing them out. There's certain things about the way OpenShift 4 deploys as well, by the way, that can be a little tricky, right? They can't the operating system team doesn't just install agents and pass a golden image over. So we believe in storing the configuration of the nodes, as much of it as we can in the cluster itself, right? It makes the cluster self-documenting. It makes the cluster the single source of truth about itself. So we think, as mentioned before, that it'd be better if all vendors sort of moved in a more cloud native, container native way. So, but getting back to the tactics of actually triaging it down, sometimes you will find a certain subset aren't required because there's some function in OpenShift 4 that actually can provide that, right? Like the log forwarding API may meet the needs of somebody. Though that said, we have log vendors like Splunk in the certified catalog. For security agents and such, it depends. If they support, if they support a Kubernetes daemon set, then you're probably not going to have a problem getting that going. If they don't have direct support, and what they end up truly requiring is a host agent installed on the base OS, we do have something of a support problem there, and in that we don't allow. We want to keep that separation very clean between the base OS and agents. So we're thinking long term about how to do that better, and how that can be managed in a more natural way. Kernel modules are a particular issue there, and that story is actually continuing to get better and better with the special resource operator, which is going to gain functionality and be integrated more into OpenShift in the future. It's not my roadmap to share, but it's but I know that there's good things coming there. So as far as kernel driver type agents, and then the third party can write their own operator that manages any other containers they might need, but then they could make use of deploying the KMod through special resource operator.
Yeah, I've pointed partners to how NVIDIA does it with their operator for adding in the NVIDIA drivers and vGPU and all that other stuff as one of the ways of doing it.
NVIDIA, Mellanox, Intel, others have basically taken the community special resource operator and then copied it. Basically made their fork and use that as a way to distribute the kernel modules until such time, depending on who we're talking about, as they get into the RHEL kernel.
Yeah. So we have a question here, and I don't know if this is a question for Derek or Mark. So more or less, it's about Rust. So are there what are the reasons, or are there reasons for using Rust, or Rustifying, I should say, not Rustifying, RPM-OS tree and other components of CoreOS?
Who asked that question?
I mean, I can give you a general answer, right? Like, and I answered this in chat as well. The biggest reason to use Rust is just the memory safety of the language that it gives you kind of out of the box. It eliminates an entire swath of vulnerabilities just right out the box. So that's my default answer to that question. I'm sure there's other reasons.
I mean, that it's a lot of that, and we're talking about really core OS layer stuff, right?
Mhm.
Where that safety is super
Incredibly important.
incredibly important. So RPM OS tree is parts of that are being rewritten, and Rust as well. Yeah. I don't really have anything else to add. I trust the engineering team for why they think something is necessary.
Mhm.
It's the same approach I take.
Yeah.
They're way smarter than me. I trust them to do what they do as best as they can do it.
Exactly.
So we do have a question. I don't know if this is one for you and me, Chris. The best way to start open source projects on Red Hat.
Ooh. I mean, on Red Hat. So like using Red Hat tooling for open source projects, because there's open source versions of everything we do at Red Hat. So I'm
And
trying to figure out
and
the
as a
question
developer,
there.
and especially a developer on an open source project, like you can go to developer.redhat.com and get access to like RHEL entitlements, all kinds of other stuff there for no charge.
Yeah, I mean, like just look at the dev sandbox, for example, that if you're watching right now, you see a link to and a QR code and now a link in chat. You get 30 days of access to an OpenShift cluster and you can just start from there, right? Or you could go grab a copy of Fedora CoreOS or Fedora itself as your dev environment and, off and running you go. There's a number of learning venues as well. Highly encourage you to go check out the OpenShift Playground, where I think it's an hour or 30 minutes or some sort, like where it's like a full OpenShift cluster all for you and off you go kind of deal. Those are two great ways to get started, I feel
over
like.
on learn.openshift.com.
Yeah.
So the I know we're down to about 10 minutes. So any questions, anything that you'll have to ask, please don't hesitate to post those into chat rather. So Derek, I wanted to ask about butane, not just a gas. It's a tool, and I'm curious about. And Mark mentioned it. When we were having our pre-meeting and all this other stuff, Mark mentioned it, and I've heard and seen the name. I don't really know what it does. So if you don't mind.
Sure. Yeah. So I guess a little bit of history here. So this is so with container Linux and Ignition. We didn't really talk about this earlier when we were talking about Ignition, but we don't necessarily recommend or expect users to write Ignition configs directly. So the spec is published. It's not documented, but that's because we're not really recommending that. It's JSON. Sometimes working with JSON's not so great. But so with Container Linux, they had a tool called Config Transpiler. And essentially what you could easily do is write some sugar YAML for whatever it is that you were trying to configure. And then you would run the config transpiler and it would generate the Ignition config for you. And then you'd pass that and deploy your nodes. The same thing exists for Fedora CoreOS upstream. There is a Fedora CoreOS config transpiler, that's kind of come from that same utility. It does the same thing. You write some sugar YAML, convert it into Ignition, and then that's what you pass when you provision a CoreOS node. Up until now, we hadn't really given users a great way to do this with RHEL CoreOS and OpenShift. But what we're doing is we're taking that Fedora CoreOS upstream project. It's been renamed to Butane. And then we're going to pull it down into the OpenShift product. And as I suggested, that will allow customers to write some sugared YAML, then convert that to Ignition config, merge that with what's been provided by OpenShift, and be able to do some of the more advanced customization that users might want to do for example, like bare metal OpenShift deployments. So like what we talked about with Ignition, disk, network, not so much. You could still do that. Ignition itself can do that. But a lot of the disk manipulation stuff, is really what the use case is aimed at the moment. So for example, if you were to take a look at a 4.7 documentation, as Mark suggested earlier, we now have the ability to do RAID mirroring on the disk. So we have this documented in the OpenShift documentation to say, okay, well, here's the YAML that you would need. It's pretty simple. Use the butane tool to transpile that into the ignition config, and then you can pass that to your installation. I can give like a quick demo if you think that might be interesting.
I would love to see that.
Sure.
Yes.
Okay. All right.
Yes.
I have to say I think the team was pretty happy that they found that there was still a like fire related term still left. They could use.
So as I suggested in our documentation, this is our 4.7 documentation, customizing nodes. Talks about mirroring disks during the installation. So you would do the normal installation, and you kind of jump over to this documentation if you want to do the disk mirroring. There is an example in here. This is the way that this is written right now was before the rename. But in this example, really all we're kind of interested in for mirroring is this bit right here. So if you've ever used the Fedora CoreOS Config Transpiler, there's a variant called RHCOS. For 4.7, we added a variant called RHCOS. And it's pretty simple, really. You want to do your mirroring. You say, okay, well, I want to mirror SDA and SDB. Now this assumes that you know which devices you have and which ones you want to use, but pretty straightforward. So I have an example of that right here. What I can do is run the config transpiler. So in the future, we're going to be shipping the config transpiler as a binary and as a Linux RPM. Today, there is an upstream binary and a container image with that binary. Just for this example, I'll be using the container image. But it's relatively simple. Just run butane against the butane config, and it's going to spit out ignition config for us. Now, of course, that would do that. There we go. So this is quite a lot of text. Hopefully you guys can see this. But remember that the sugar YAML that we've written, really straightforward, just mirror these disks together. Mm-hmm. The ignition config that actually gets generated, it's pretty complex. Like the config transpiler is doing all of this work for us. So if you aren't familiar with this bit right here, essentially what this says is look in this particular directory for my worker.ign file. This is the one that OpenShift install generated for us. And then what it's going to do is it's going to merge this into this file for us. So that's what this part of the ignition config is at the top here. It's gzipped base64 encoded version of that file. And then underneath, we've got our storage directives. So we need to do something with our disks. We need to create some file systems on top of them, and then we need to do RAID on top of that. And as you can see, this is all pretty complicated. The config transpiler does all of this work for us. It figures out the labels for the partitions. It generates GPT, UIDs, etc. Defines the size of the partitions that we want and the file system labels, and does all the work with MDADM to set up the software RAID devices for us. So this is pretty nice. This gives us a nice shortcut to here's the really simple operation that I want to do, but I don't need to understand all of the intricacies of disk manipulation to write an ignition config in JSON. So I think that's a pretty good example of.
I mean, as someone who's created, I'm going to say extremely basic ignition files before, knowing the syntax and the nuances and everything else, this makes me really, really happy. So do you have, or is there a list of the types of configuration that are supported by butane? And you said sugared YAML, which I'm not familiar with that term. I think it means like basically a specific syntax or something like that.
Yeah, just a specific syntax, just an easily consumable format. So I'm just kind of using that as a shortcut.
Some things that butane will translate are going to look almost the same in YAML or JSON, right? It's just going to be the formatting, but the sugar is those 4 lines expanding out to like 87 lines, as that's where butane is doing the heavy lifting to calculate all this out and make sure it all matches. It's taking care of, also notice it's taking care of the boot partition as well, making sure that that's mirrored. Because there's no point in if you lose your root device, there's no point if you can't boot off the other drive.
Yes, that would be bad.
So you were asking about the spec, I guess.
Yeah, well, it kind of like you had a very specific, as Mark said, 4 lines for doing mirroring of the 2 boot disks. Are there other operations or other things like that are possible?
Yeah. So let's take a look at some of the examples here. So the examples in the upstream CoreOS butane repo are specific to Fedora CoreOS. For the most part, the RHCOS variant is a subset of the FCOS variant. So most of these examples should work. You just need to change the version. We haven't really talked about Fedora CoreOS and what it means to RHEL CoreOS, but it doesn't have the same use case upstream. It's more of a standalone, something that you're encouraged and in most cases required to customize. So that's why there's more about how to interact with Ignition and use the Config Transpiler for those use cases for Fedora CoreOS than there are for RHCOS. But some really, and the reason I say that is because there's some really simple examples in here. So like, here's how I would define SSH keys for the default core user. Here's how on Fedora CoreOS I could create another user. You could do that on RHCOS. Ignition will allow that. That's not something we generally recommend that customers could do. Let's see.
Thank you for skipping over password authentication.
So file systems and partitions, there you go. So if you wanted to create, if you wanted to manipulate secondary disks like SDB in this example, this would be an example of how you could do that. This in this example, it's taking SDB, making a file system, mounting that at var. It's going to put ButterFS on top of it. So,
and just to complete the thought process here. So, excuse me, the example you showed was of short and simple, right? Of take the worker ignition file and append this configuration for mirroring the disks, and then that output is what you would then provide to your nodes when they're booted.
Yep. So if we go back here, all I need to do is save this output, this ignition config, and this is what I would pass to my node. So if I, for example, all of my workers, I wanted to raid all of my workers, and this is an important distinction, is they all have an SDA and an SDB. Then you could generate this file once and use this to provision all of your workers instead of the original worker.ign file. And it would include all of the changes from the worker.ign plus all of the changes that you need to do the RAID configuration.
So we're at the top of the hour, and I want to be respectful of everyone's time. We do have one last question. So if you want to take just 2 or 3 minutes to answer that. So Sai asks, how do we get started with RHEL CoreOS? Don't see much in terms of documentation, at least to understand and compare with RHEL, especially RPMOS tree.
I would
That is a-
answer that question kind of counterintuitively. I would say you don't get started with RHEL CoreOS, right? Like you get started with OpenShift and then you use RHEL CoreOS with OpenShift. But I understand that some people think I need to understand the foundational layers first. So RPM OS tree would be the thing that you really need to understand the most, I feel like. Is that fair to say?
Possibly as well as Ignition. I think,
obviously, yeah.
I Fedora CoreOS is in a way a good way to get started. Yes. You can look at it as a standalone container host. It also can be clustered, and I used under OKD as far as I know.
Yep.
But the upstream documentation for RPM OS tree and Ignition is pretty solid, and it's we can put links in, but it's not too hard to grab. That would be my advice. There's also ways, it's distributed as a live ISO as well. So you can just take the ISO file of 4.7 plus, I want to say,
4.6 plus,
4.6, and just fire that up as a diskless VM on KVM or anything, right? And you just boot it up.
Yeah.
And I mean, if you're curious about, what will you do after that? I don't know. You can use the RPM command and see what's installed.
Run some containers on it.
Yeah. And
Podman's there. So yeah, it's possible.
So I think Sai might be flirting with something that we talked about in the meeting that we had yesterday, sort of the pre-brief for this. And that is, a lot of times RHEL admins will approach CoreOS and think of it the same way. And really, CoreOS, especially in the context of OpenShift, is meant to be more appliance-like. And you can inject configuration via, why did my mind completely went blank? Ignition or
machine config operator.
Yeah, so you can inject configuration before installation via Ignition. But after deployment, it's managed through OpenShift. And so you have a series of operators: machine config operator, file integrity operator, tuned operator, right? You have all of these things inside of OpenShift that do the post-deployment configuration. The goal being, hopefully, you don't have to connect to the CoreOS node. You don't need to SSH in and do administration. Rather, it's done through the cluster itself.
I would add, though, that that when you do SSH in, you won't feel completely on it, not at home. It's different because of mainly the package manager will probably be the first thing people run into and wonder what to do there. But that's pretty straightforward to get around. Yes, it is. It's really first and foremost a component of OpenShift, and that's kind of the way we look at it, as an opinionated version of RHEL for OpenShift.
Okay, well, I think we're out of time. I know we're out of time. We're 4 minutes over. So thank you, Mark. Thank you, Derek. Really, really appreciate you spending time with us today. It's been a pleasure having you on. I've learned a ton today. I hope that this has been informative to our audience. So for anybody who has a question that you didn't want to ask publicly or we didn't have time to get to, please feel free to reach out to me. Andrew.Sullivan, first name, last name, @redhat.com. You can also reach out to me on social media, Twitter, Practical Andrew. So if you've seen me posting in the chat here, it matches my Twitter username. Welcome to send me messages at any point in time. Chris as well. He now has a nice, convenient, easy to remember email address, short@redhat.com.
Yes.
I'll stop getting those confused now.
Yeah. No, at C short, there's too many C's, right? Like you can spell C in so many ways. You don't necessarily know just by saying it. So yeah. But short@redhat.com and Chris Short, all one word with 2 S's in it, on Twitter. Feel free to reach out anytime. I just dropped a link to our Discord. You can join that as well and DM us there if you need to.
As well as Kubernetes Slack. We're on there as well. And keep an eye on openshift.com/blog. Friday morning is when we'll post the blog post that has all of the follow-ups, links, timestamps, all that other stuff inside of there. So Thank you, everyone. Thank you again, especially Mark and Derek, for joining us today, and have a great rest of your day.
Thank you
Thanks,
all.
guys. Thanks, everybody.
Thanks.
Appreciate it.